Hello, everyone. My name is Kenin Naokafo. I am a teacher at Corona Secondary School. And today we'll be discussing a concept called computational thinking. But before I proceed with that, I would want to say one or two things about the work that Coderina is doing, that is trying to raise awareness about computation. We live in an age where computing is so important. Our lives are interwoven, with software. And so any society that is really desirous of developing must pay attention to ICT. Okay, so I encourage others who have these skills to, be a part of this drive by Codarina to give our children, to give the students and the general public a chance to understand what programming and programmatic thinking is about. Okay, so that's that so far. Today we'll be looking at computational thinking, and to some extent we'll be looking at execution of very basic codes in Python, using Python. But our focus really it's about the thinking that is behind the software that we see. It's the thinking behind our ability to solve problems. So I'm going to share my screen to illustrate some of these issues. Okay, so um, it's very important that we first of all understand what we expected to have at the end of this training. Number one is that we need to be able to talk about computational thinking in terms of the definition. Then it is also important that we are able to describe the aspects of computational thinking. What are the components of computational thinking? And then we should be able to give examples and illustrations. And then thirdly, we need to be able to explain the features of algorithm, because the component of computational thinking is a subset of computational thinking is algorithmic thinking. And some people would even say that computational thinking is the same as algorithmic thinking. And so what are the features of algorithms that we'll be looking at? You should be able to explain these features. And then we need to, to some extent, look at how computational thinking would help us would come in the classroom as students. How are we going to apply computational thinking in, our learning, in the learning process? And then lastly, we should be able to, solve basic problems using algorithmic constructs, algorithmic processes to be able to problem solve, because that's what thinking is about, right? Computational thinking is about solving problems. So what are these processes? We need to use the processes involved in algorithmic thinking to solve problems. All right, so that's that so far. So guys, if I would ask you, what would you say what would you say computational thinking is? What would you say computational thinking is? You could leave a message. You leave a message on the chat box if you think you can handle. You want to tell us what computational thinking entails. Anyone? Okay. All right. So while we're waiting for comments and all, I'll just read. Computational thinking, as the name suggests, is a way of thinking. So it's a thought process. And so you have this particular way of thinking that involves thinking in steps, just the same way a computer would. And there are four components of computational thinking. I'll share my screen again for ease of understanding. Let's look at what the components of computational thinking are. And so you see there that computational thinking entails decomposing a problem. And so the first thing, when you are confronted with a problem is to actually break it down, because many times looking at the problem as a whole pose a challenge, for us. Try like breaking a bundle of broomsticks. It will be much harder to do that. But we can simplify the process by breaking individual broomsticks. And at the end of the day, we realize that, oh, we've actually broken the bundle of broomsticks just by taking them one after the other. So that's what decomposition, is like. Break down the problem, solve those subsets of the problem, and in doing that, you would have solved the problem in its entirety. And then abstraction, of course, you are confronted with the problem, and with the wording or phrasing of that problem, you may not use all the words, in that expression, in the expression of the problem. So you should be able to pick out only the vital or relevant data or pieces of information that you would require in solving the problem. And that's what abstracting is about. You abstract the problem, you focus on what is relevant. Okay, focus on what is relevant by removing unnecessary details. Just like a teacher asking students in an English class to summarize a passage. You don't want to bog yourself down with unnecessary details. So you focus on the important details, and that way you are able to come up with a summary of the passage. So we also apply summary skill in computer science, by way of abstracting a problem. And then, of course, it is important to be able to recognize patterns in life. There are patterns, and our ability to see them would make a lot of difference. And so events happen and they reoccur. There's a recurrence of events. And that way we can search for patterns so that we're able to make predictions and also make decisions based on the patterns we've observed. And that's what it is. So sometimes if you go online, on Netflix, they make suggestions about movies you would love to watch, and you realize that they do that. The AI, is able to do that based on a recognition of the pattern of movies that you have actually been watching. So pattern recognition is very, very important. And then the last there is the algorithm. That entails having the steps you would take, definite, clear, unambiguous steps you would take to arrive at a solution, to arrive at your destination, which is the solution to the problem. So that's what algorithmic thinking entails in a nutshell. Let's not forget the components: decomposition, abstraction, pattern recognition, and algorithmic thinking, which broken down would simply mean using algorithms in solving your problems. Okay, so let me take a break there now, see if we have suggestions. Hello, Abdul Martin, are you there? All right. Okay, so continuing our discussion on computational thinking, let's now examine each of these components. Let's elaborate further on each of these components. So we'll take decomposition. As we discussed earlier, decomposition is about breaking down the problem so that it's easier to manage. You have smaller manageable chunks of the problem at hand. So let's look at a typical scenario where decomposition is found. Think of a wage. Someone's an employee or a worker should earn a certain amount in wages, right? And so you think about the problem. You want to break it down. How do I consider the number of hours? That piece of information is very important. And then we look at the gross pay given the number of hours. So for a unit of time there, for 1 hour, what should be the pay? And then I add up, the pay for the number of hours we have. So I need the gross pay, I need information about the number of hours. And then, of course, just before you pay the worker, you want to make those necessary deductions. It could be contributory pension, it could be income tax. So you make those deductions. So we need to know what the tax is, and we need to know what amount of pension should be deducted. And then we eventually get the difference between what we had as the gross and the sum of the deductions made. So that way we know what the net. That way we know what the net pay is. Okay, so that's what decomposition is about. You see that in calculating the wage of a worker, I approach the problem with certain questions in mind. What's the amount of time? How many hours are we looking at? That piece of information is important. And then we know how much the person earns per hour. So we do the sum of the wages per hour. And then we also, before we pay this person, we make the deductions. So you see, I'm breaking down the problem. So I first of all would know how many hours. I would get the amount of pay for the number of hours. And then I'll look at the deductions to be made. The taxes add up and the pension, contributory pension adds up. I get the sum and I remove from the total wage so that I know how much the net is, how much is the person actually taking home. So what's the take home at the end of the day? That's one way of looking at the composition. All right, so moving ahead, we also will look at abstraction. Let's consider. Oh, before I go on, please let's look at another scenario. Where the composition is used as well. This a number of items total do you get that? Let's take some seconds of a number of items at a distance 40 naira. So what idea is about composition do we have? Is the items. I need to break it down, right? The items need to know for the number of each of the items I am buying. So I need to now add up goods.
Okay. Um, okay. Hello, everyone. Can you hear me? Um, Sorry about the lost connection. I think everyone can hear me. My voice is not breaking, right? Sorry about the lost connection. So I'm going to be taking over from where he stopped. Okay. So okay, I think he's back. He's back. Okay. So before he comes back, um last time, if you joined my class, if you were in my class last for the last week, Saturday, you will see that we talked about we introduced ourselves to Python. We talked about how to install Python, how to print things on your console, and we also tell you that Python is just like English is like English. So you just write it and it's very simple. So what we're going to be talking about today is going to be we're going to be introducing ourselves more into Python. Okay. So I don't know what he was talking about before. I think he's talking about computational thinking. So but now I'm going to be telling you about Python. Okay, I think he's back. So let him continue from where he stopped. Please continue from where he stopped.
Oh, network.
Oh, okay. We are very sorry today. I think the network is very bad. So please just bear with us. I think today, okay. So I'm going to be talking about Python now. I think those that are here for Python class also. Okay, so um the Python is very simple, like I said in the last class. So today we are going to be talking about variables in Python, how to create variables, data types. And in the last class I said you guys should create a very simple program in Python. I don't know if you do that, if you did that. Uh, so I said you should create a very simple program. Maybe it's just print hello world. Last time we also did print hello world. I told you different cases of how Python is easier to write than other languages, how it is very short in writing. Maybe for instance, in other languages you may write like for a very simple program you may write like 6 lines of code, but in Python you just write like 3. I hope you all can hear me because somebody is saying the network is not good enough. I hope you all can hear me. So I'm going to be continuing from where we stopped the last class, where I said I'm going to be introducing you to variables now. So I'm going to share my screen now and show you what variables is about and the data types and different things. So we're going to be writing different things in Python today. Okay, so I'm coming. Yeah. Okay. So now I'm going to share my screen so you all can see my screen. I'm sorry about that. Okay. Okay. Uh-huh. Now, so we're going to be starting with what. So you're formally welcome to the second class of Python. So you're formally welcome to the second class of Python by Coderina. So what is Python? What is Python variables? So Python variables are containers for storing data, data values. Unlike other programming languages, Python has no command for declaring a variable. So for other programming languages, for instance, JavaScript, like I said in the last class, if you were in the last class, I'm going to repeat myself now again. So I said JavaScript, for instance, if you want to create a variable in JavaScript, you have to use something like var, which is variable, let, or you can use constant, const. So you can use any of that to create your variable. In C++, for instance, you have to use int, which is integer. You have to use string, str. But in Python, what you just have to do is write, for instance, x is equals to 5. If you can see on your screen, I gave an example there, which is x is equals to 5, y is equals to LO, then z is equals to 67. So something like that. You don't have to write anything before the x or before what you want to put your value inside. So a variable is created the moment you assign a value to it. So as soon as I say x is equals to 5, as soon as I assign 5 to x, that means x is now a variable. Also, a variable can only store one data value at a time. What that means is you can't say x is equals to 5 and maybe you put a comma, then hello, then a comma. No, you can only do one at a time. You can only do x is equals to 5, y is equals to hello, and z is equals to 67. So those are examples of data that's a Python variable. You can also use different other things. You can use for instance, you can say name is equals to Abdulmatin. That name is a variable. That name is a variable. So you can use different things. Class is equals to different things. So we are going to be talking later on. We're going to be talking about the rules in creating variables in Python. So, variables do not need to be declared, like what I said before. Variables do not need to be declared with any particular type. You can even change the type after they have been set. What we mean by that is, I say x is equals to 4. Since now I have set 4 to x, which is 4 is inside the container x. X is a variable, which is a container, which is holding 4. And x is of the type integer. Since we are setting 4 to x, 4 is an integer. So now our x is also an integer. Since 4 is an integer, our x is also an integer. But if later on, I don't feel like putting 4 inside our variable x anymore, I want to change it to another thing. So now I say x is equals to string. As you can see on the our example, you will see x is now a type string, str. Str is a short form of string. Int is the short form of integer. So x is equals to string. So now what is inside our x is string. It's no more 4, it is now string. So this you can see this hash here, hashtag here. So what that means is to write our comments if you want to comment in Python. So now we are starting to write little programs in Python now. So you can see now this is to write comments. That means I don't want to run this thing I'm writing. So I don't want it to run when it is running my program. So it's going to see it as comments. Okay. So now strings variable can be declared either by using single quotes or double quotes. So if I want to declare my string variable, I don't have to use only double quotes. I can also use single quotes. For instance, you can see here x is equals to Sally. I'm using a single quote, and this is a string. X is equals to Sally also, while I'm using a double quote, and this is also a string. Like I said before, str is the short form of string. So I'm going to stop sharing my screen now. I'm going to ask you um I'm going to let you ask some questions. Okay, so can you start asking your questions? I want to know if you've understood what I've been saying since. So this is last time I said, Python is as simple as English. It's just like learning English. So even a 6-year-old can learn Python. So please, I'm waiting for your questions. If I'm too fast, can you say? If I'm too slow, can you say? Can you tell me what you've gained so far? Okay, how do you declare a variable? I said in Python you don't declare a variable. Once you say x is equals to 5, that means x is automatically a variable. You don't have to use anything to declare a variable in Python. For I said in C++ you have to use maybe like int, which is an integer. You have to do, instead of saying x is equal sorry instead of saying x is equals to 5, you have to say int x is equals to 5. Int x is equals to 5 for C++. That's for C++. Other programming language, maybe for JavaScript, for instance, you have to say var x or let x be equals to 5. But for Python, you don't have to declare anything. You just have to say x is equals to 5. Since our 5 is an integer, it is automatically an integer. Okay, so unlike other programming language, Python has no command for declaring a variable. Yeah, a variable is created the moment you first assign a value to it. Okay, so that's just what Python is. That's as simple as that's very simple in Python. For other programming languages, you have to just start learning what do I have to use to declare a variable. But for Python, you don't have to learn anything. You just have to say maybe name is equals to Abdul Martin in a quote, which is a string. So even if a number is in a quote, that means that number is a string. We're going to be getting to data type. So data type string is part of Python data type. So we're going to be talking about data type later. So let's continue with our slides. Okay. Okay, so let's continue with. Okay. So rules in creating Python variables. I said before that I'm going to talk about the rules in creating Python variables. A variable name must start with a letter or the underscore character. That means you can start your variable name with a letter. In maybe for instance name, you can start your for instance name, or maybe I say class, or maybe I say book. That is, those are variable names. Those are things we can hold our value inside. Those are containers. And an underscore, like I say, underscore my name. Underscore my name is an example of a variable. But you can start a variable with a number, for instance. You can start a number with a number, for instance. So a name cannot be started with a number. You can start a variable name with a number. A variable name cannot start with a number. So you can start a variable name with a number. For instance, if I say maybe 2 then name, that's a wrong variable name. It's going to give you an error anytime you create a variable name with a number. So a variable name can only contain alphanumeric characters and underscore. Though you can't use numbers to start your variable name, but your variable name can contain numbers. It can contain A to Z. It can contain 0 to 9 and underscore. It can't contain some special characters like it can contain full stop, semicolon, all those kind of character. You just have to use maybe name 2, book 2, something like that, underscore my name, underscore my book, my underscore name, something like that. You can't use dash or things like that. So variable name are case sensitive, which means age, you can see the difference. This age is starting with a small letter, this age is starting with a capital letter, and this age is um capital letter all through are totally different, which means if I say age is equals to 10, and I'm using my small letter all through, and I want to say maybe you should print age, and instead of using my small letter all through, I started with capital letter. It's going to give you an error. It's going to tell you that there is no um variable with that name yet. So there's no variable with that. That's what it's going to give. It's going to give you an error. I hope you all understanding what I'm saying. Uh, so age and age are totally different. So anytime you want to create your variable name, you have to be case. You have to make sure it is. You have to be um case sense. It has to be case sensitive. So let's continue. Assigning value to multiple variables. Okay, so Python allows you to assign values to multiple variables in one line. Example is xyz is equals to John, banana, and Sally. This means instead of me writing x is equals to John, y is equals to banana, and z is equals to Sally, I can also write x comma y comma z is equals to John comma banana comma Sally. You can see I'm using a double string, a single string, a double string. It does not mean you can use either double string, single string. This is just to show you an example. So I don't have to just um keep writing it on different line, saying x is equals to John, y is equals to banana, z is equals to Sally. But Python allows you to write the same if you're assigning it to assign multiple values in one line. And you can also assign the same value to multiple variable, though you to multiple variables in one line, though you can't assign um different value to one variable, but you can assign the same value to multiple variables. I hope you get what I'm saying. What I'm saying is you can say x is equals to John, x equals to John, banana, and Sally. That's not possible. But I can say x equals to y is equals to z is equals to John. What I'm saying is instead of writing on different line that x is equals to John, y is equals to John, z is equals to John, no, I don't have to do that. I can just say x is equals to y is equals to John. That's saying it's still the same thing as saying x is equals to John, y is equals to John, and z is equals to John. Okay. So if you have any question, you can start asking your question. So okay, let me see. So do variables follow a specific code, or you can choose whatever you want? Like I said before, you have to follow the rules in creating the variable, though you can use any variable you want, but you have to follow the rules in creating the variable. You have to either starting with a letter or starting with an underscore. You can start with the number or a special character. Okay. So let me see any other question. You can ask your questions. So maybe this is what you can do. You can see all those examples that are there. You can open your Python and type in those examples. It will give you the right answer. And the ones I'm saying that are wrong, you can also try it. You'll see that it's going to give you an error. Um Okay. So this presentation is going to be shared with you, and by the end of the class, I'm going to give you an assignment so you can do your take-home assignment too and submit. Again, I'm going to be telling you where to submit to. Please the code for the classroom. I was trying to use let me see. Do anyone have has everyone installed has anyone installed Python yet? Please, if you have installed Python, just say you have installed it so I can move to I can start using Python to um teach to write some code. And I have something called instead of using Python, you can also use you can download Spider or different. I last time I said they had IDEs and text editor you can use to write Python, and you can also use the Python command line. But if when you're writing something big in Python, you have to use the IDE instead of using the Python command line, or maybe Sublime. Maybe you're using text editor or IDE. So you have to use IDE to write a very big program in Python. You don't have to use the Python command line, so you can run. So I'm going to be switching to Spider now. Let me open my Spider and so I can show you different codes. I'm going to write different codes and show you if it's going to give you an error or not. You can also go to just type in Spider on your on Google, and it give you it's you can download Spider from there. And you can also use your I just want to use the because that's very it's to show you what I'm saying. I just want to use the how about Atom? Yeah, you can use Atom. Atom is a text editor. You can use Atom also. You can use Atom to write your code also. So I'm about to open Spider now. Spider is a lot easier to use than the Python console. So you can use since text editors and IDEs are better to use than the Python console, because it's going to give you your answer right away. It's going to give you if it's an error, it's going to show you an error, or if the Python code is going to run, it's going to give you it's going to run the Python code for you. So I'm coming. Let me open my Spider so you can see all what I'm talking about. So it's giving a little bit. Um, Spider.
Mm, okay, so while we are waiting for my co-facilitator, I'll continue the discussion on the components of computational thinking. So we've looked at decomposition, and we were beginning the discussion on abstraction. And so we said that abstraction is just simply a way of removing information that is not needed, that is not necessary. So that is not all that is not necessary. We take off so that we can focus on the important details. All right. So let's look at an instance of abstraction. Look at this now. Sharing my screen. Let me share the screen here. A moment. Okay. Just a moment, please. Where is it? Okay. So here you have this you have abstraction here now. You have this problem. There are 90 people in a line at a theme park. Every 5 minutes, 40 people get on the ride. So every 5 minutes, 40 people get on the ride and 63 join the line. So how long do you think it will take 600 people to be in the line? So that's like estimating the amount of time it will take for us to have a particular output. So remember, we're starting with 90 people, and as Abdul Martin, my co-facilitator, mentioned, you have something called a variable in Python. So it's like a container, something to hold our value. Just like having water, but we need to put the water in a container so that we can access the water whenever we need it. So that bucket or the bowl is a variable. So to store our value of the number of people at the theme park at that particular time, we have a variable which I call begin P. P there stands for people because of space. But it's good that we make our variable names as descriptive as possible. So I can also have for a variable name, I could also have beginning number of people. So that would be a valid variable name. Okay, but here I've used begin P to stand for the value of the number of people at the theme park. And then we have the time. So we set the time as a variable to 0 because we're going to build up from there, from 0 minutes, and then we keep increasing. Okay, so we keep increasing there, and then going forward, we also need to have a variable for what I call the new P. That's a variable. The variable name is new P. And what value does it hold? That is the number of people that join the line. So 63 people join the line. And then a fourth variable is we hold the value of the number of people that get on, people that get on the ride. So that's 40. So let's take it again. 90 people at the theme park, 63 people get on the line, and 40 people get on the ride. And so now we're asked to calculate or estimate how long it will take for us to have 600 people in the line. And so that's a question taken from Google. So let's look at it now. Let's look at the abstraction. You have a word problem, so many words, but I am not interested in what information all the words in this word problem has. So I'm going to focus on the important. Draw out the pieces of information that you would need in order to actually solve the problem. So that's what I'm going to do by means of abstraction. I'm going to get the number of people at the theme park. I'm going to get the number of people who join the line, the ride, and then the number of people who join the line. So that way, I'm able to now compute, or do my estimation. And so I have Python. I've written the code there in Python. Later, in course of this training, we'll look at a concept in computational thinking called looping. So having to do something repeatedly. So if I have to, for example, get the names or display the names of all 100 students in my class, it's not something that I want to. I want to get all the even numbers from 1 to 1,000, for example. Let's take that example, 1 to 1,000. It will not be easy, for me to actually write the numbers one after the other, 1, 2, 3, when I can simply just ask the computer to go through itself, run through all the numbers 1 to 1,000 and output them, show them on the screen. So that's something that you can do with a loop, having to do something repeatedly, like output numbers from 1 to 1,000. So here now I've used this particular loop here now. So while the number of people there at the theme park does not exceed 600, it doesn't exceed 600 because we are told, we're asked how long it will take for us to have 600 people. So we don't need more than 600 people. And so we begin. So the number of people there will increase. In what way? I have the number of people and a certain number of people join. That is the new P. 63 people I add that to the 600 people at the beginning, the first minute, and then I'll remove the number of people who are actually getting on the ride. I mean, getting on the ride. So 40 people join the line. Sorry, there's an error there. That should actually, I set it to 90, please. It's 90, not 600. That's a mistake, not 600, please. So 90 people, I'll keep adding the number of people that get on the line and keep removing the number of people that join the ride. So repeatedly, at the end of the day, when I reach a figure that is now more than 600, I'm going to stop. Then I'll take a look at the time. Remember, I keep increasing, the time keeps increasing. So there's a way of actually telling us how many minutes the time has gone up. So I'll add to whatever time I have, I will add an extra 5 minutes to it. So that there has to be a way. Any looping must have a way of making the condition not valid, false. So I achieve that by adding to my time. All right, so then I have something called a flow chart. Remember abstraction, we are taking off information that is not important, and so we are left with the bare bones. The 4 pieces of information there: how many people do I have at the park, at the theme park, what's the amount of time, and what's the maximum time, how many people are joining the line, and how many people are getting on the ride. So with that, I can actually now compute how much time it will take for us to have 600 people. All right, so but that's not, because we haven't actually introduced looping, we wouldn't go into that. Okay, so now let's look at, I'm going to display something. Looking at pattern recognition, we'll see if you can actually identify or recognize patterns. Just a moment. Let's see if you can recognize patterns there. Okay, so what do we see? Oh, sorry, just a moment, I lost that. Okay, so here we have series of patterns. So my question now is, looking at the first pattern, you have the smiling faces. Which one of them is actually not like the rest? Let's say you have this as a task. Which one of them is not like the rest that we're looking at? Anyone there? Anyone? You could leave me a message. All right. So I don't know if this is large enough but we can see here that this particular face has a longer set of eyes, like vertically, unlike the others. So this one over here is a different one. I'll send this particular slide to the participants, so you actually have the time to look at the information again, in your own leisure time. All right. So now, what is pattern recognition, and why is it important? Nothing, or very few things in life do not come, in a defined set of patterns. And so our brain over time has been trained, our brains have been trained to identify patterns, in nature. And it is important, like I said earlier, programmers use patterns to make predictions. So Yahoo, for example, would know what sort of news items to present to you based on the sort of things that you have been reading. Netflix would make suggestions about movies that you would like to watch based on the kinds of movies that you have been watching. So that's something that we do by pattern recognition. It's simply looking at patterns, and you could also design or create your own patterns for solving different problems. So you establish a pattern that you automate the process, so that even when you are not there, the computer just follows using the pattern that you have already designed or established. That's what pattern recognition or pattern design is about. And then the last thing I will talk about there is the algorithm itself. What is an algorithm? So let me share my screen there, so we can see what an algorithm is. Just a moment. Just a moment, please. Okay, so that done, I'll share my screen. All right, so let's see, algorithmic thinking. We learned that algorithmic thinking entails drawing up a step-by-step process of solving a problem. So you create steps, and let's remember that the steps must be finite. You don't want something that is going to run forever and ever. So those steps, from the beginning to the end, that is when we arrive at our conclusion or our solution. The steps must be finite. There must be an end to the number of steps. And then the steps must be clear. You leave no room for confusion, as we perhaps have learned, garbage in, garbage out. So if your steps are not clear, there's no way others will be able to follow, or even the computer will be able to follow your line of thought. Your steps must be clear, and then your steps must be definite, and it should be able to be automated. So those steps should be able to be automated, followed by perhaps another person or a computer. So those are some of the attributes or qualities of algorithmic thinking or an algorithm. And let's look at this instance. You want to make a hot drink. You want to make a hot drink. You want to make a hot drink here, right? So from the beginning of that process to the end, can we draw up steps to follow in order to have a cup of tea in my hand that I can drink? So we start. You check if there's water in the kettle. So if water level is 0, add water to the kettle. You see now? So I add water to the kettle, fill kettle. And then I am going to use this thing, I call a loop. to check what the when the water begins to boil. So for every rise in temperature, I will check 1 degree Celsius, 2 degrees Celsius. So I'm running through temperatures from like 0 to that we know that water boils at 100 degrees Celsius. So using that loop, I'll check, is it up to 100? Is temperature up to 100? I will keep, running, going back and forth, round, until the water gets to a temperature of 100 degrees Celsius. Then I will now ask, which one do I want when the water has got to 100, the temperature of the water has got to 100 degrees Celsius? Is it coffee? Now, if it's coffee, you see, I'm going to ask a question, so there's decision to be made. If it's coffee that I need, then I'll add coffee to the kettle. But if it's tea, I'll add a tea bag. So that's that. Then you ask, do you want milk? Depending, again, that's another case of decision making. If milk is needed, then add milk. If not, if milk is not needed, then you do what? Continue to the next process. And remember, if I chose tea, I add a tea bag or 2 tea bags, right? And then milk needed, yes or no? If yes, add milk. If no, continue. And the next in line, if it is tea needed, I am to extract the tea bag that I put in the tea. And then finally, I would have my drink. So you see the step-by-step process of making a hot drink. So I don't know if anyone has a question. Now think of this. Can somebody give me a step-by-step process of events or things done from the point of waking up to leaving the house in the morning? Let's say you are a student. Of course, you are students now. The point of waking up and then leaving the house or the hostel in the morning. Can you draw up an algorithm? All right, so that's something that, perhaps as an assignment, you need to think about, and you draw up an algorithm. One thing again, in drawing up algorithms, we must decide on what format it is going to take. What I have here is a flow chart. Right, which we'll discuss we'll discuss in subsequent lessons. So let me see, Abdul Martin. Let's see if so, guys, we'll talk more about flowcharts, pseudocodes, and control flows in subsequent lessons, and we'll be implementing some of these ideas using Python programs, that's writing Python codes. Thank you. And Martin. Okay, he's.
So I brought my spider up now. My spider is up now. So I'm going to be showing you the examples of what we have been saying since, so you can actually see what I've been saying instead of just reading it in the presentation. So I'm going to share my screen. Come in. Okay, I'm coming. Okay, so this is what the I hope you can see my screen. This is what the our spider is going to look like. This is what our spider is going to look like. So I hope you all can see my screen now. Okay, that's so this is what our spider is going to look like. This is our spider application. It's running on Python 3.7. So our spider is running on Python 3.7. So I've written an example here, which is x is equals to cool. Then I want it to print x. So once I run it, um, you can see it's printing cool. Like this is our console. This is where it's going to be printing everything. Here is our console. Here is where we're going to be writing our program. Okay, so you can see x is equals to cool, which is cool is a string. So x is equals to cool. So print x is going to print cool. So now if I say like I showed you before, I said that we can assign a single value to different variable. So I'm going to show you an example of that now. X is equals to y. Sorry, x is equals to y is equals to z, which is equals to, let's say, John, which is equals to John. Okay, so now I'm saying x is equals to y is equals to x is equals to, x is equals to y is equals to z is equals to John. So I want it to print all of them out. So let's say print, okay, print y, then print z. So I'm going to run it. This is to run this play button here. You can see is to run file. So now let me run it. You can see John, John, John. That's what I was saying before. You can actually assign, just instead of me writing x is equals to John, y is equals to John, z is equals to John, I'm just going to write x is equals to y is equals to John. Okay. So what again did I say? Okay, let's clear this up. And variable names, I can, like I said, you can use different variable names. You can use name is equals to Abdul Mateen, which is my name. Okay, so now I want it to print the value name. I'm going to click on the play button again, so you can see it's printing Abdul Mateen. But for instance, now if I create two, if I, instead of using uh you can see it's already flagging an error, invalid syntax. You can see that. That's why I said you can only use a underscore or a letter to start your variable name. You can't use a special character or a number. But for instance, now if I put my 2 here, you can see there's no error. It's not flagging any error because it is correct. Let me see. Okay, so it should print name 2. Let's run it again. You can see it's still saying Abdul Mateen. But if I should put a special character or a number before the name, that means I'm using a special character or a number to start my variable name. It's going to flag an error. Okay, so let's go back to our slide. Okay, so sorry for me. Let me share my screen again so you can see my slide. Okay, so this is my slide. Back to my slide now. So to output variables, like I just did now, was outputting a variable. In Python, the print statement is used to output variable. You can use your print statements to output your variable. Like I just showed you that print x, print y, print z. It's actually outputting what our variable is contained. What is contained inside our variable. What our variable is holding. So what is inside our variable, that's what our print statement is going to actually print out for us. I said x is equals to John. So now I'm saying that it should print X. That means I'm saying that it should print whatever is inside X, which is John. If I say X is equals to Abdul Martin, I'm saying that it should print out Abdul Martin. So to combine both text and variables, Python uses the plus character, which is the addition character. So actually, I can add my variable. For instance, I'm saying x is equals to cool, for instance, now, and I'm saying that it should print Python is plus x. That means it should print Python is plus whatever is inside x. Like I explained before, I said print is printing out what our variable is containing. So x is containing cool. Now I'm saying that print Python, which our Python is inside our quotation, so it's going to print out Python is, then plus the x, which is our variable. You don't need to put that inside a quotation because it's already holding in something. It's a variable name, so you don't have to put it inside a quotation. Before, when I showed you an example in the last class, I said print hello world, and that our hello world is inside a quotation mark. It's inside a quotation mark. That means we don't have anything holding, we don't have a variable name holding our hello world. We just want to print out hello world. So now that's what I'm saying. That's the same thing I'm saying here. I'm saying that you should print Python is, which is inside our quotation. We don't have anything holding our Python is. So plus whatever is inside X, you should print it out. So Python is cool. So it's going to print out Python is cool. So again, we can also use it to add two variables together. For instance, now if I have my this Python is, for instance, if I have it, maybe I say y is equals to Python is, then I say y, you should print out y plus x. It's going to print out, it's still going to print out Python is cool, because there is something holding my Python is. I don't have to put it inside the quotation, inside the print statement again. I just have to refer to the variable which is containing my Python is. Then you can see the example here. I say x is equals to the food, then y is equals to is sweet. Then I say z is equals to x plus y, which is saying that I add whatever is inside x, which is the food, which is a string, and add whatever is inside y, which is sweet. And once you add both of them together, store it inside z. So now, after storing it inside z, I'm telling it to print out z. So whatever is inside z now, print it out for me. Let's see what is inside z. So now it's going to print out the food is sweet. Um you can also use the addition character to add numbers together. You can use it to add, like if I say 5 plus, if I say x is equals to 5 plus 10, which is going to give you 15. Then if I say I should print out x, is going to print out 15 for me. But you can't add maybe two data types together, maybe a string and a number, or an integer. You can't add them together. For instance, if I'm saying that you should add maybe I'm saying x is equals to the food now, and I'm now saying the y is equals, instead of this is sweet, I'm saying is equals to 5. Now here I'm saying you should add x plus y. It's not possible. It's going to flag an error because they are of two different data types coming. Okay, so um I think that's going to be all for today. That's going to be all for today. We next class we're going to be discussing the variables and sorry, the data types and other things in Python, what you can use, what you actually writing some clear programs to build some things in Python in the next class. So as you've seen here, you can, your assignment will be to maybe create a variable name, uh, putting something inside that variable, then maybe creating two variable names. For instance, x is equals to, like you've seen before, x is equals to the food, and y is equals to a sweet. Then you add both of them together inside another variable, then you print it out. You can do that as, you can take that as your assignment. So if you have any quick question, let me see. So is there any other question? Is there any question you have so I can quickly answer that? I want to round up now. Okay, see, I don't see any question. So I'm going to round up. So thank you for um which year am I in? Fourth year. I'm in my fourth year. I'm my fourth year now. So thank you for listening to this beautiful Python program now. So you can take a break and go to your next class. So thank you and bye.
Uh,